Okay, so now we have a fraction under the radical sign. And that's okay. We're going to have a rule for it in the next video. But for now, we're just going to work with the fraction. So I'm thinking about 75 over 48. And that will actually simplify, right? So you could think of it as 3 times 25 and 3 times 16. And those 3's would cancel. So I can simplify this expression to the square root of 25 over 16. Well, 25 is 5 times 5, and 16 is 4 times 4. So I can think of it as 5 over 4 times 5 over 4. And then that's going to simplify then just to 5 over 4. Now, if you were thinking back here, well, I was just going to take the square root of 25 and I was just going to take the square root of 16. Yes, that's what we're going to do. We haven't had the property yet that says we can do that, but it is what we're going to do. Okay. So now we want to do a cubed root, but we've got 54 over 250. So I'm going to think of that as the cubed root. 54 is 2 times 27. And 250 is 2 times 125. And so then I'm going to have the cubed root, oh, those 2's cancel. So I'm going to have the cubed root of just 27 over 125. So if it helps, you could think of it as 27 is 3 times 3 times 3. And 125 is 5 times 5 times 5. And so you're going to get just 3 over 5. Okay, so when we can reduce these fractions, it really helps us because in these cases we've been able to take the cubed root then. Okay, now we want to do a fourth root. So I'm going to look at my 32 over 62 and see if I can get that to simplify. So it's 2 times 16 over 2 times 81. And then those 2's cancel. So then that gives me the fourth root of 16 over 81. And then you could say, well, that's, 16 is 2 times 2 times 2 times 2. And 81 is 3 times 3 times 3 times 3. You could split them all up. Anyway, there's 4 of them. And so you're going to get 2/3. All right. I'm hoping this makes some sense. And now we're going to have some variables. Okay, so again, we can simplify. Now, the rule for exponents is if you have a to the m over a to the n, then that equals a to the m minus n. So I don't know if you remember that rule, but that's what it is. So if you have, in our case, we have a to the 8th over a to the 6th. So that's just going to equal a to the 2nd, because it's 8 minus 6. It's a to the 8 minus 6. Okay? Well, the square root of a squared, that, oh, I bet they're going to want an absolute value on this. Oh, I wonder if I forgot to put absolute values on the other video. I'll have to go back and check. All right. That's that one. Why do I have to have the absolute values? Because remember, we don't know if a is positive or negative, and it's an even root. So, yeah. So, that's that one. All right. Now we have the fourth root of x to the 4th. So, I'm going to have, it's got to be absolute value of x, because it's an even root. All right. And we don't know if x is positive or if it's negative. All right. And then we've got one more. So it's going to be the fourth root of y to the, now take 17 and subtract 5. So that's going to be 12. So think about how many times 4 goes into 12. It's going to be 3 times. So y cubed. And then do I need the absolute value or I don't need the absolute value? I need the absolute value because it's a fourth root. It's an even root. But I've got an odd exponent, so I don't know if my y cubed is going to come out to be a positive or a negative. Okay, I think that's it for those.